Hello and welcome to another video on Joe's Physics Corner. Today we're going to solve question 2 of the PUPC. I'm continuing from the previous video where we solved question 1 over here. Okay, so today question 2. Let's read the question first. A point particle with mass m and velocity v hits the edge of an equilateral triangle with mass m and moment of inertia 1/4 ml squared. The particle and the solid triangle are located on a flat, frictionless surface. Okay. So, and the question wants us to find the velocity of the particle after collision, the velocity of the triangle after collision, and the angular velocity of the triangle after the collision. Okay. So firstly we've got 3 variables, so we're going to need 3 equations to represent these in terms of these variables given from the question: m, small m, big M, velocity v, and moment of inertia. Okay, 3 equations. Well, if we need 3 equations, the 3 that comes up to my mind is 1, conservation of momentum. Number 2, conservation of angular momentum. And number 3, conservation of energy. Now for number 3 here, we're not sure if this is an elastic collision. So we're not sure whether this could be used in this system. However, because the question wants us to find 3 variables, the value of 3 variables in terms of these given variables, we can infer that we have to use all 3. We have to use 3 equations. And because when we only talk about the momentum, we only get 2, we could infer from the question itself that we have to use conservation of energy. Okay, so conservation of momentum first. What equations can we derive by conservation of momentum? Well, first, before we do that, these variables here, it's going to be really hard if you're trying to rearrange them in the future, because they, it's small m, big M with dashes here, with dashes here. It's it's really hard to mess around with them if we're gonna rearrange it, divide them in the equations in the future. So to make that simpler, I'm gonna say, well, initial velocity here, I'm gonna say that's equal to u. So this, I'm gonna say it's u. I'm gonna say that the velocity of the particle after collision is going to be v, just simple, and that the velocity of the triangle after collision would be, what would be a good variable? I'd say that could be big V. Big V is also quite. Yeah, I'm going to say it's big V, and I'm going to make it really clear that it's big in the equation. And then the angular velocity of the triangle, I'm going to say it's just omega, because there's only one angular velocity that we're interested in. Okay, so we have V, we've got big V, we've got U, we've got M, we've got small m, we got omega. And these three variables are the variables we want to represent by the variables given in the question. So okay, number 1, conservation of momentum. What do we know? Well, we know that initial momentum, Pi, has to be equal to PF. Okay, and what's PI? Well, PI, there's only one particle moving in before the collision, which is this ball with mass of m, and the momentum it has would be mu. Mass times initial velocity of the ball, mu. And what's going to be PF? Well, PF is going to be, there's going to be 2 systems that are moving, which is the ball over here and the triangle, the center of mass of the triangle over here. So that would be mv, because we're talking about the velocity of the particle after collision, and we assigned it as small v, plus big V and the big M, big V, because the mass of the triangle here is big M, and the velocity of the triangle after collision is big V as we assigned it. And I'm gonna make it extra clear that it's a big V, and this is a big M. Right, it's kind of V. Is there a better way, better variable than big V? Because it's gonna get really hard to see. I'll say this is Y. I'll call that Y to make distinction even clearer. And I'll say M. I'm gonna assign M as N. I'll say M is gonna be N. So the mass of the big one is gonna be N. So PF now is gonna be MV plus NY. Okay, MV plus NY. Okay, so the first equation we get, because PI should be equal to PF, we get number 1, MU is equal to MV plus NY. Now let's move on to the conservation of angular momentum. Okay, what would be the angular momentum? So it's the same, PI. We use the principle that PI equals PF. But now PI would be the angular momentum of the system. And there would be only one particle, one entity that makes this angular momentum, that has angular momentum before collision, and that would be also this ball. And when you draw the diagram over here, this is the center of mass of the triangle, and that's the ball right before collision. You know that's gonna be U, and in the diagram we know that the length here is gonna be L. And so what would be the angular velocity? Well, we know that angular velocity L is equal to P times the radius, the distance between the entity and the center of mass. We know that angular momentum here is equal to just linear momentum times the radius. And so we know that because the linear momentum we define here as mv, it's gonna be wait, what? Yeah, mu over here. It's gonna be mu times radius, which is L, MUL. And now what would be angular momentum? It's gonna be Li equals LF, and Li is equal to MUL, and LF is gonna be, well, after collision there would be two entities that has angular velocity, and also angular momentum, and that would be the triangle over here and also the ball here. And now the angular momentum of the ball here would just be MVL of this thing here, this entity here after collision, using the same principle that linear momentum times radius times distance from the center of mass is equal to angular momentum. And the only thing that changed is that V here is now the velocity after collision, so we replace U by V and we get MVL. But plus we mentioned that the triangle also is going to spin. After it hits here, it's going to spin like that. And so what would be the angular momentum of that triangle? Well, we know that angular momentum is I times omega. I times I, which is the moment of inertia given here, times the angular momentum. And for now, we're just going to leave it like that, MVL plus IW. And yeah, at the moment, we're just going to leave it like that. Omega being the angular velocity of the triangle after collision. We mentioned that we're going to represent this by omega over here. Okay, so we've got this equals that, Li equals Lf. So our second equation we have is MUL is equal to MVL plus IW. And so let's move on to number 3, conservation of energy. Okay, so conservation of energy is also same. Energy before collision is going to be equal to total energy after collision. So what would be the initial energy, the energy before collision? Well, EI, there's only one entity that's moving, and Therefore, the kinetic energy that this entity has before collision is going to be the initial energy, which is going to be 1/2 mu squared, because u is the velocity. Okay, then what would be EF? Well, EF would be, again, 1/2 v squared now. U became v after collision. And it also has two other forms of energy. It's got the triangle's rotational energy, the triangle's what should I say? Rotation, angular kinetic. You get what I mean. It's 1/2 I omega squared. That's the rotational energy. I forgot the name of it. The angular kinetic energy. Along those lines, it has this rotational kinetic energy over here, and it's also got just linear kinetic energy, which is 1/2. Now we called it n, right? 1/2 n y squared now, because that's the kinetic energy of the triangle itself, the center of mass of the triangle, just moving whatever direction it goes. But that would also have kinetic energy like that. And so we have, because EI equals EF, this is going to be equal to that. And so we got a third equation, which is, when you multiply both sides by 2, it's going to be mu squared is equal to mv squared plus, let's do that first, ny squared plus I omega squared. That's going to be our third equation. Okay, and now we have to find, let's just write them all down. Number 1, mu equals mv plus ny. Our second one, mul is equal to mvl plus I omega. And number 3, mu squared is equal to mv squared plus ny squared plus I omega squared. And the question has given us that I is equal to 1/4 ml squared over 4. That's given in the question here. And yeah, these are the information given by the question. And we have to represent omega, v, y, and omega in terms of m and u and l. That's our task. Okay. Let's just now we don't need this over here. Okay. How are we gonna do this? Well, first let's just represent v. First we could eliminate the number of equations in the 2 by saying that, well, we have the first equation here, mu is equal to mv plus ny. And so mv is equal to mu minus ny. So we get v is equal to mu minus ny over m equal to u minus n over my. Okay, so we have this equation. So we have just eliminated the number of variables from 3 to 2. We're representing v in terms of u, n, m, and y. In terms of y, because we're considering these as just constants given by the equation. So we have represented v by y. So we have eliminated the number of variables from 3 to 2. Okay, so let's manipulate these equations again and say, well, number 2 is now going to be, it's mul plus mvl plus mul equals mul plus iw. And so when we substitute v in with that, we get, well, mul is equal to m times v times l. So ml times this, which is going to be mul minus ml. We're multiplying ml, so ml nly n over my times ml is going to be, yeah, nly nyl. Let's see, mul minus nyl, and also plus I omega. And for the second equation here, the third equation here, we get mu squared is equal to m times v squared, which is u minus n over my squared, plus ny squared plus I omega squared. And we know that I is equal to ml squared over 4. Okay. Okay, now we have this. Now what can we do from here? I omega. What can we do from here? I think we could, from this equation, we could represent y by. Okay, let's look at the second equation. We have MUL is equal to MUL minus NYL plus I omega. So we could eliminate these parts, and we get NYL is equal to I omega. And I, we just said, is this. Okay, so NYL is gonna be ML squared omega over 4. And so L disappears, so NY is equal to ML omega over 4. Now, that doesn't satisfy me in any way because we still have omega here. Or when we represent y by omega, then we could substitute omega into here and get y into here and get an equation only in terms of omega. And will that give us the answer? Maybe? Wait. Wait. No, I think let's look at number 3 first. Because doing this is gonna give us such a complicated equation in terms of omega. I mean, it would be possible, but I think doing this first would be an easier way. Okay. So we've got I equals MUL MVL. Okay, okay, let's just write NYL equals I omega down first. Okay. And so what do we know about omega? Well, omega would be NYL over I. Okay, so that's a better simplification of a variable in terms of another variable. So it's NYL over I, which means that omega squared here would be n squared y squared L squared over I squared. Then let's substitute this into that, and we get, because it's I multiplied by this, we will only get one I over here. And that would give us a better equation that we could then use to derive y. Okay, so let's substitute this part here into here. Okay, so we get mu squared is equal to, should we expand it? I think we should. U squared minus, when you multiply, un over m. So 2un over my plus n squared over m squared y squared plus ny squared plus n squared y squared L squared over only one I, because I squared and I is being, well, I times I squared over 1. I times 1 over I squared will be 1 over I. Okay, so let's expand it once more, the brackets. Minus m and m cancels out, so 2uny plus n squared over m y squared plus ny squared plus n squared y squared L squared over I. Okay, we get this into 0. Are we going to use the quadratic equation? Or maybe there is no need. Wait. Okay, mu squared. Okay, let's isolate. Okay, so we got 2u and y. Now we're going to here. It's equal to, let's wrap everything up by y squared. Is it right? Okay, wait. Okay. We could divide because every single element here has y in it. We could subtract y from everything, divide y. So we get, now when you do the same thing, we get only 2un. Now it's equal to n squared over ny plus ny plus, okay, now we get a linear relationship. So that's when we wrap this up by y, it's going to be n squared over m plus n squared l squared over I. And that's going to be 2un. And, well, okay, and because every single element here also now has an n in it, we could say it's equal to ny. We could, get n out of here, the bracket, and say it's nm over 1 plus only 1n over I. And because now we have both n's here, we get 2u is equal to y times n over m plus 1 plus nl squared over I. Okay. And we know that here, from this here, we know that I now is equal, let's now substitute L now, I now, into this form here. So NL squared over I would gonna be times 4 over ML squared. It's gonna be L squared 4n over m. So y times n over m plus 1 plus m over 4n now is equal to 2u. So that's going to be n times, that's going to be n plus 1 times m is equal to m plus, 4n equals 2u, and that's going to be 5n plus m. The camera, So y is equal to 2u times m over 5n plus m. So m plus 5n. That'll be 2um plus 5 plus 2um over m plus 5n. That would be our y value. Okay, so we got our y value. We only there's only u, m, and n. They're all given by the equation here. So we get, when we do it in the when we re-represent these variables by the variables given in the question that we are asked to derive in, we get, you said y here is equal to v prime m, so we get the first part of the answer, v prime m is equal to 2u. You said this was v here, originally the value was v, so we're just saying it's u for simplicity, so we're saying 2 vm over m plus 5, and n, we said it's big M originally, so it's going to be that. That's going to be the first answer. Okay, let's move on to so now we have y. We represented y as 2um plus, now it's, everything else is just easy because we know that y now is that we could substitute this into, let's say, we have this over here. We have v is equal to u minus n over my, and we know y, so when we substitute this into that, we'll get v. So v is equal to u minus n over m times y, 2um over m plus 5n from here. And so we do that and get u minus 2un over m plus 5m. That's going to be equal to, when we make the denominator the same, we get this times that um plus, oh wait, this has got to be n, sorry. Yeah. plus 5un minus 2un, so it's equal to plus 3un over m plus 5n. So it's going to be u times m plus 3n u, yeah, over m plus 5n. That would be our answer to this over here. Wait, u minus, let's just double check if it's right. 2um over 5 plus m plus 5n. Right. Yeah. Oh wait, I think I made a mistake. So. Yeah. Oh, I is not that. It's not ml squared times. It's gonna be nl squared over 4. And so we will have, that will mean it's nl squared times 4 over nl squared. So they all disappear. So we only get them. It's just plus 4 here. And so we get m over n plus m plus 4m. So we'll have, it's gonna be swapped like that. So this is gonna be n, this is gonna be m. So m plus 5, n plus 5m. So our answer here will not be that. It's gonna be v prime m is gonna be 2vm over denominator. I mean, this would stay the same, the upper part would stay the same, but we'll have, it's not small m plus 5 big M, it's going to be big M plus 5 small m. And here, let's just erase all that. We have y is equal to 2um over, it's going to be n plus 5m, not m plus 5n. So, okay. We do the same thing, y equals u minus n over my. It's going to be equal to u minus n over m times 2um over n plus 5m, which will give us u minus 2un over n plus 5m. And do the same thing, we say it's that, and say un plus 5 um minus un is going to be equal to minus un plus 5um over n plus 5m. So we get minus u times n minus 5m over u plus 5m, n plus 5m. Yeah, and for simplicity we just minus that and swap these around. That looks better. We get that over here. So when we represent that, do the same thing. We said u here. No, this is y. No, this is v here. So we said v here is v prime small m. So v prime small m now is equal to u is v times 5m is same minus n is big M over here over big M here plus 5m. That would be our answer for the velocity of the mass, velocity of the small mass after collision. Okay. And now we move on to the last part, which is the angular velocity omega. Let's just get it here. So let's just write down the answers we have, because they're going to be useful. We get y is equal to, and v which is v is equal to u times 5m minus n over n plus 5m, and we're going to get omega. And so let's find the use of omega in a different question. Do that one. Omega. Do we have an expression in terms of omega? Yes, here. We said that omega is equal to, when you look at camera, when you look at that over here, we said omega is equal to NYL over I. And we have a y, L is just a variable given by the question, and I is, again, be careful, this is n, L squared over 4. And yeah, so omega would be, we know n times y, which is 2um over m plus 5n times L, which we could just use over n L squared over 4. That's going to be our omega. How do we simplify this? Well, we say this is our multiplication, so 2u m n L 2u m n L over m plus 5n times that, swap this around, reciprocal, and n L squared. Got n here together, L squared off. Yeah, so we get 8um over L times that, so ml plus 5nl, and I guess that would be our answer for omega. And omega, we said here is y prime m, so y prime big M here is equal to a times u is v times m over ml, same, plus 5 big ML. Yeah, that would be our answer for omega, the angular velocity of the triangle after collision. Parts B and C. Part B. Under certain conditions, a second collision will occur between the rotating triangle and the point particle. Second collision. How does that occur? You know, I'm gonna do like that, and then if wait, the time. The video is getting too long, so I'm gonna stop here. And for the next video, I'm gonna solve part B here of question 2. So thank you. It was Joe's Physics Corner, and remember to always enjoy physics. Thank you.